Welcome to Study Loop.
So the Chinook winds, when they descend on the slope, they create a change of temperature in the surrounding areas, and they melt the snow, or they simply increase the temperatures. But observe that this is a very sudden process, and then there is no time to exchange heat in this process. Therefore, this is an adiabatic process, or delta Q equals 0. So in these kinds of processes, from the first law of thermodynamics, we know that any heat exchange is equal to the change in internal energy plus the work done. Therefore, for this case, the change in internal energy will be equal to the negative work done. So the work is done on the wind and on the gas that is moving. And there is an increase in internal energy of the gas, which is related to the negative work done. And therefore, the temperature of the gases is increasing, and the wind is actually increasing the temperature. But this is an adiabatic process. This is not, there is no actual heat exchange, but this is enough to actually increase the temperature and cause, for example, melting of the snow or something like that. So this is for the part A of this problem, and for the part B of this problem, we need to actually find the change in temperature if we take into account the known values. So the elevation of Denver and Great Peaks is given, where the elevation of Denver is 1,630 meters, and for the Great Peaks the elevation is 4,350 meters. We also know the air temperature and the air pressure for the Denver and Great Peaks, which is given in the problem in degrees Celsius. So we will transform this into the temperature for Denver. Initial will be 275.15 kelvins. This is when we convert it from the given 2 degrees Celsius. And for the Great Peaks, it will be from negative 15 Celsius, 258.15 kelvins. Also, the pressures or atmospheric pressures are given, the air pressure for each location. So we can, since we know that this is an adiabatic process, we know that the next relation must stand. The pressure in Denver on 1 minus gamma times temperature in Denver on gamma is equal to the pressure in Great Peaks 1 minus gamma times T in Great Peaks on gamma. And from here we can derive the relationship which says that TD TGP on gamma is equal to PGP or PD on 1 minus gamma. Then we will raise both sides to 1 over gamma and obtain the ratio TD or TGP to be equal to PGP over PD and 1 minus gamma over gamma. Gamma in this case is going to be 1.4, since this is air we are talking about. So from here we can say that TD, but this is TD, not the initial value, but the value after the Chinook winds go down the slope. So I have to make a small statement here that this is TD0. TD is equal to TGP times pressure, the pressure GP over, and here we will have 1.4 minus 1 over 1.4, and we can substitute the values, the known values. This is going to be 258 times 15.15, and here we'll have 8.12 over 5.6. These are in pascals, and this will be 2 over 7. And of course, it is all in dimensions of kelvins. So when we evaluate this, when we put this into a calculator, we obtain that TD after the Chinook winds is 287.9 kelvins. So the difference, to find the difference, we need to actually say this to convert this into Celsius. This is 13.95 degrees Celsius, and therefore delta T, which is a change in temperature, is equal to delta TD minus delta TD0, which equals 13.95 degrees Celsius minus 2 degrees Celsius. And when we subtract these values, finally we obtain that the change in temperature is 11.95 degrees Celsius. So the temperature will increase for this amount in degrees due to Chinook wind, which arrives in Denver. And this is the end of the problem. I hope you find this helpful, and I hope to see you in another lesson.